The
Yeah.
wrong button.
This meeting is being recorded.
Yeah.
Okay. Okay, so let's begin design patterns. So to start with, what are design patterns? Why do we need design patterns? So as software developers, most of the times when we are coding, we evaluate our code by certain attributes, as in how clean our code is, how fast our code is, how expressive it is, how much memory is it going to take, and so on. But one important aspect that we sometimes often fail to recognize is how much will it take, or how costly will it be if we are to change anything in the code, if a new requirement comes in, for example, and which is not new in this world of agile deliveries and continuous development and so on. What we are doing today can all be irrelevant tomorrow or after a week. So we need some kind of basic principles or some kind of pattern that helps us define how to design our code or how to structure our code so that it'll be easier to maintain, easier to extend, etc. So design patterns is nothing but a template or a best practice which aid in programming to solve very common problems while designing an application or a system. So these are proven solutions. They are reusable. We don't have to reinvent the wheel or anything. They have already been defined, and we just need to evaluate them or evaluate the design and then apply the design patterns as and when needed. They ease in refactoring the code. They help in keeping the code maintainable, extensible, and also loosely coupled. As you might, loose coupling is one of the criteria that if some of you had attended the solid principles, you would have learned it then. So these are not ready to code solutions. They are just a pattern on which the solution should be based. Design patterns can broadly be classified into these three categories: creational, structural, and behavioral. And today I'll be covering the creational patterns. So what creational patterns do? These are concerned with the way in which the objects are created in a system or in an application. Basically in Java and in many other languages as well, you would have come across new operator, which is used to create objects. But what might happen with the new operator is that it might scatter the objects all over the application. Without you realizing over time that the system and the application have become quite tightly coupled. The classes become quite tightly coupled, and it becomes difficult to maintain the classes. It becomes more complex, etc. So which is why we do have creational patterns. There are a bunch of them. There are 5 creational patterns that we will be going through today. And those have a definite set of principles on which they are based, and all of them can be applied to different scenarios. So let's go through them one by one. So the structure, the format will be, we'll take an example, we'll consider a scenario, and then we'll see how it looks like before applying the pattern and after applying the pattern. Factory pattern. Now let's consider this scenario where we are owning a car service company, and we provide cars as a mean of transport to our travelers or the users. Initially, we provide only small cars, but soon the service becomes famous, the demand increases, and we intend to expand to bigger cars and luxury cars. So like we have 3 set three types of cars involved here: small cars, bigger cars, let's call them sedan cars, and luxury cars. So our purpose is to provide that as a means of transport to our users. Does anyone have any initial thoughts on how can we, like a very simple approach, and how can we solve this problem? You can like either drop a message or probably raise a hand and we can talk through. Or I can proceed.
Sorry, I think I've got an idea, but I'm not sure. We can kind of start with a method and then later on, when the program gets bigger, we can kind of, I guess, add more methods that are relevant to what we're doing. For example, we can have like a method that's small and then later like add different methods.
Yes, I mean, you are on the right track. So essentially, maybe we kind of define an interface and then extend it for smaller cars and bigger cars and luxury cars. So it would look something similar to this. Like we start with defining, a car interface, which would have like three methods, let's say name, model. Just to keep it simple, I have just defined three methods here. And send car is the actual method which the service should be using. Like when a user requests, we should use this method send car to send that particular car to the user. And because we have three different types of cars defined, we use a small car, which can extend that interface. And then you can define the methods here. And similarly, we can define sorry. And similarly, we can have two other classes called sedan car and luxury car, which will implement the car interface and will define all of those methods and put in the details. So this will be the initial structure. And then finally, to implement that, we will have something called a car service, which will ask the user for the input, and based on the car type, it's going to either create a small car or a sedan or a luxury car. And it throws an exception if the car is not recognized. And finally, after the car has been created, this particular function here, car.sendCar, actually is called to send that particular car to the user. Now, a problem with this approach is that we have coupled the creation of the car with the main car service, which is sending the car to the user. Now, our main method or our car service method should not have to worry about creating the particular car. It should only have to do it only has to send the car based on whatever the request is. So that to address this particular problem, what can be done is we can create a factory and we can delegate the entire logic to that factory class, the creation logic. So factory, as the name stands by, it literally means like you create all the, you put all the creation logic inside that, and no matter how many types of cars you want in the future, or if you're adding any other modes of transport, everything, all of that is going to be bundled inside that factory. So that is separated out of your main service class. So after applying the factory, how will this code bit or this problem be solved? So this is how the car factory will look like. what I have done is just created a simple method called create car, and then which takes a type, which is a string type here. And based on whatever type is provided, it either creates a small car or a sedan or a luxury car. Now, as we saw from the previous slides, this entire part, this part here, where you had the type defined in the service class, it was taking an input and then we were creating the cars. We have taken this entire logic and put it in a factory class. That is how the factory looks like now. And when we define our service class, it should look like this. You have a car service, you enter the type, and what you need to do is just instantiate a car factory and then create the car based on whatever type it has. And now the service class only job is to send the car, which should be the primary function here. I have a small video just representing how the different types look like here. So if you see, this is just a simple test and I'm building the different types of car. Yep, that's it. So just 3 types of car, and I just create a car factory and instantiate them. That's the factory method. Okay. This is how the factory pattern is represented in a diagram. So you have the creator here, you have the concrete creators, you have the concrete products to build the actual product. And as we saw in the previous example, that was a very simple example, but this is the general pattern to put in whenever we want to apply the factory pattern to a particular design problem. The question is, when do I use this pattern? How do I know when to apply this pattern? So when the current implementation is designed in a way that it cannot comfortably accommodate any new changes, when the implementation of the interface, for example, that you have defined is expected to change frequently. Let's say we want to add more types of cars, for example, or more modes of transport like 2-wheelers or other kind of 4-wheelers, etc., to our service. So in that case, it's always good to put it in several different factories and then use them while creating your cars, while creating your objects, and then finally calling them from the client or the service method. And when your constructor has only a handful of parameters, like we just saw, now the example that we saw had just 1 parameter. Even if it has 2 parameters, maybe then it is easy to design a factory pattern. There are other patterns, there are other creational patterns that we will later see, which also deal with not when more than 1 parameter, or like when you have a bunch of parameters that keep on changing when you want to design the application. In that case, there are other patterns. But yes, when the design is relatively simple, we can use the factory pattern. So these are the pros and cons. All the patterns have their pros and cons. It is up to us to identify whether you do have enough pros to go on and use that pattern. One of the main pros for the factory pattern is that it does follow the single responsibility principle of class design. It does help in keeping the application loosely coupled. And it also follows the open-closed principle of class design. Now, all these 3 would have been covered in the solid principles for those who would have attended. And these are quite essential when you kind of design a class from scratch or even try to rethink your solution. So factory pattern caters to all of these pros. A disadvantage of factory pattern might be that as you keep on increasing the number of subclasses, your code might become a bit complicated. So that might affect the maintainability. But again, as I said before, it is up to the kind of task that you have in hand. If it you are the best judge of whether the task can accommodate a factory pattern or not. But yeah, I mean, in general, the factory pattern should be quite simple and maintainable to use. So that's it about the factory pattern. Do we have any questions before I proceed to the abstract factory, which is an extension of the factory pattern?
Sorry, just like a very general question on design patterns. So when we see, for example, the creational one, there's, I believe,
Yes,
5. So yeah, there's 5. So do you just pick one, or do you have to use all of them in when you're building a project? How does it work?
Yeah, so you can't choose all of them for a single project. You might or you might not. So it really depends on the task that you are supposed to build. All of the creational patterns have very specific uses. Although all of them are considered with the creation of objects. However, let's say factory and abstract factory, they are kind of closely related in that they help you build families of objects, for example. But the singleton and prototype patterns are very different from each other. So prototype helps you in like cloning of objects, as we will see further down. So essentially, it will all depend on what is the problem that you're trying to solve, or what is the kind of class that you're trying to design. And it will just all fall into place once you probably have seen how all the patterns work. They all cater to very specific needs. So does that answer your question, Naima?
Yeah, it does. Thank you.
Okay. Okay. All right. So let's proceed then to abstract factory. So let's say, going back to the previous example, we have our car service company, but we decide to take it global. We decide to take it to multiple locations to expand our business because it's going so profitable. So we'll start with 3 locations. We'll keep USA, we'll keep India, and we'll keep UK. So we have these 3 locations where we want to build our cars, and then we want to expand our services. So the problem that we have in hand is we'll need to figure a way of creating small, sedan, and luxury cars at 3 different locations now instead of just 1. So how do we solve this problem? Any thoughts on what we might need to change in our code, or what we might need to introduce in our code to address this problem? Anyone? Okay, so let me proceed then. So we can create factories based on a location parameter. So because we now know that we have 3 different locations, and then we have 3 different types of cars to cater in those 3 locations, we'll create factories based on the location, and for each individual location, we'll delegate the creation of the car logic to that respective factory class. So how is the code going to change after application of this particular pattern? Now, the interface that we had declared, that was called a car interface, we'll make a slight change in that. We will be putting a location parameter. We'll be putting a location parameter in that. And we will be declaring this as an abstract class, providing its like own method as well as some common methods which the other classes can define themselves. So this location parameter is actually going to help us define the car creation logic in the different factories. So this is the change that we have done here for the car class. And now we go to this small car, sedan car, and luxury car classes, which we have made another change in how now they accept the parameters and how they would look like. So that is the small car class, which now accepts again a location parameter. And then it can be now instantiated based on that. And the name and the model and the other parameters remain the same. Similarly, you have the sedan car also following the same practice, and the luxury car, again, the location parameter. And all of these cars are now built in separate factories. So you have a USA car factory, and similarly, you have the other two factories. Now, what this does is the method build car that will just accept the model. And when you provide the model, that's going to instantiate the car, the small car, or a sedan or luxury, depending on the type, with a location parameter. Location here has been defined as an enum, and it has 3 values for now: USA, UK, and India. And we are going to build cars, and this particular method build car in the factories is going to accept the location based on wherever we are building it from. So this one is essentially going to call on this method, this constructor. And let's say we have passed a luxury car. So the location is going to be location.usa. It's going to build this car, and we have calling on the construct method as well. So it's going to probably print this statement here, building luxury car, and then get the model from here. And similarly, the other two as well. So that's the USA car factory. Similarly, we will have a UK car factory, which is going to accept in location.uk for all the building of the cars, the various types of the cars. And an India car factory, which will accept the location as India while building all the cars. Now, these are the 3 car factories. And now, how do we use them when we are calling them from our main class or from our service class? Yes, so this is again another, so we had the different car factories, and the different location-based car factories. This is the main car factory, which is going to accept a type and a location. And based on the type and location, it's going to give you whatever car needs to be built. So this, let's say, for example, the type is, the type is small and the location is UK. It is going to call upon the UK car factory with a type of build car small, which means that it's going to go to that factory, go to call small car, and give it a location of UK, and then build it accordingly. We'll see that in the example. There's a small video to show that, but this is how our main class is going to look like. We enter a type and we enter a location, and then we call upon the car factory with that type and that location. That's all. And then that is going to build your car for you. So let's just see that in this video. This is how, so that's my main class. And when I run it with different parameters, this is, okay, it's running with, let's say, sedan, and the location is UK. So it says building sedan car, this model, and the car has been built in UK. Now let's run it with other parameters. The car type is luxury and the location is USA. So that says building the luxury car of model this and the car built in USA. So essentially that is how we can define our parameters here and then extend the abstract factory to create different types of cars. So I think that is it. I have, yeah. So let me exit this. Okay, so that is all on abstract. Yes, that's the overall structure diagram for an abstract factory. Now, abstract factory is majorly used to create several families of objects which are linked through to each other. Let's say going forward, like the example that we just saw, maybe you want to introduce more modes of transport or more number of locations to build them in, or have more number of features to the cars that you defined. So it's always better to delegate all of those things, delegate all related things to factories, and then call upon them based on what are the different types that the user wants to provide. So as you can see here, abstract factory, that's the interface. And then you can define concrete factories, which implement that interface and create products. Create concrete products, and the client that only calls on this abstract factory, and then it provides some kind of choices, and based on those choices, either of the concrete factories are called. So that is the diagram for abstract factory. How do I know when to use this pattern? One thing is when the client is quite independent of how we are creating and compose the objects in the system. We have also seen that in our first example where we did not want the client to be concerned or bothered with creating a car object. So most of the times it will be like that also in our practical environment. So when we know that the client is wants to stay ignorant of that, yes, we can go ahead and use the factory or an abstract factory pattern. And as I mentioned earlier, if there are multiple families of objects, and all those only by grouping all of those objects or by using all of those families, you can design the entire application. So if in that case as well, abstract factory will be a good candidate to use. And also a runtime value is needed to construct a particular dependency. Now, as we saw, to create the cars in my previous example, we needed a type and we needed a location. There might be few other features that are few other parameters that might be needed to construct that particular object. So in those cases as well, I can go ahead and kind of use this pattern at ease. The pros, the advantages of using this, again, loose coupling. It provides quite a good amount of loose coupling, keep the classes independent from each other. And it also promotes consistency among products because it kind of groups families of objects. It creates a single factory to solve one purpose, and then you can have a major factory to combine all the minor factories and create the actual object. So in that way, this can prove to be quite clean and maintainable while using the abstract factory. A disadvantage of this, as in with the factory pattern in general, is that as you keep on extending subclasses, your code can also become too big and complex and kind of difficult to support new kind of products when they come in. because you have to go ahead and then change your factories to add new kind of products every time, and subsequently all of its subclasses. So that will be a major disadvantage of using the abstract factory. So again, that depends on whatever problem you're trying to design or solve, or the given task in hand. If you know that, okay, this is something that will not demand adding many new products in the future, or if you know that, okay, this will always be limited to a fixed set of parameters all the time, then yes, it is a good decision to use that. But over time, if there is a scope of that getting complex, then it might not be a good decision then. So that's all about abstract factory. Okay, before we move to the builder pattern, do we have any questions on this one, on factory or abstract factory? Okay, I can't see the chat. So Irina, if there are no questions, then I'll just move forward.
All good.
Okay. Okay, all right. The builder pattern. Okay, let's consider this problem, or rather a scenario. Now, if any of you have ever looked at a Tesla website, what they essentially do is there is a base model of the vehicle that you want to choose, and then the user can kind of add features onto that based on their liking and based on their need. Now, how can this particular thing be handled in a code? One option is by telescoping a constructor and like having all possible combinations. Now, what exactly does telescoping a constructor mean? So that means something like this. You have a vehicle class, you have like the features associated with it, ID, name, model, location, and color. Now, one approach can be to have several different constructors with several different initialization parameters and then handling it that way. But is this approach indeed a good way of writing the code? What if we are to introduce a new parameter here, a new feature here? In that case, how will the code look like, or will it be a good practice to actually keep on doing this this way?
You have a suggestion to use decorator pattern.
Sorry? Yeah, Irina, go on.
From Bakali, you have suggestion to use decorator pattern. The message in chat says like decorator pattern maybe.
But will that solve, but this is about, we are speaking about how to create that object. Doesn't decorator fall in after we have built the object and want to put in different parameters? Okay, so yeah, I mean, this is something that we are talking about at the very initial stage of when we are essentially creating that particular object or creating that particular vehicle. This is one way of doing it, but this is a very bad way of doing it. Reason being, the number of constructors are actually going to increase a lot if you provide several parameters, more and more parameters. So what the builder pattern does is, builder pattern suggests that we keep the object construction in a separate class called builder. We have a builder class which will build the particular objects, or which will create the objects based on whatever parameters are provided it to. So we don't need to define telescoping constructors. we will be handling all the cases using the features that are selected by the user. Now let's consider that we have to build our service to cater to 3 different kinds of vehicles here: cars, trucks, and motorbikes. Now, all of these vehicles are quite different in like features, in their look, and in their colors, for example, the model, for example, and you can have relatively more than 100 possible permutation and combination of what you want to add to these different types of vehicles. So for simplicity, we will just keep like 3 basic features, and we'll go through how it would have looked like if you did not apply the builder pattern versus how it would look like after applying the builder pattern. So this is a very simple product class. What this does is, the main purpose of this class is just to show the product that has been built and to add different parts to a particular product. When I say product, I mean all the different types of vehicles that we are supposed to build here: cars, trucks, and motorbikes. So we'll be adding parts to them using the add method, and we will be looking at what are the things that are added using the show method. So this is a car class. What it does is it just has 3 different parts that have been added: the body, 4 wheels, and 2 headlights. And then when you do a get vehicle, it will return you the product. Similarly, we have the other 2 classes, the motorbike and the motorbike, and we have the truck. So the build vehicle is the one which actually adds the product, and the get vehicle is the one which returns the truck object here. So this is how our main class or the client class looks like when we enter the choice that we want, the type of the vehicle that we want to build here. So this takes in the type of the vehicle, it creates that object, it builds the vehicle, and then it gets the vehicle based on whether the choice is car, truck, or motorbike. And then finally, it does a product.show. The problem with this particular class is, again, that as you keep on adding different choices or different choices of products to your service, this particular method goes on increasing and increasing because you have to build vehicles based on the different number of permutations that you provide. And also, because this is the client class, again, this should not have to worry about accepting all the choices and building them and then showing the product. So all that is quite a bit messed up here. How you can clean it is by creating or moving all of that to a builder pattern. So we define a director. The director is the class which is actually accepting a particular type, and then it builds it. So that's the main class which is building the product body, the product parts, etc. in the construct method. The builder interface, on the other hand, the builder interface is exposed to be implemented by all the different kinds of vehicles that we have, and that provides with the kind of the methods which we want to use in our different classes. That's the builder interface. Now, the 3 different methods that we had seen earlier that were defined in the main classes, I have moved them to the builder interface: build body, insert wheels, and add headlights, and the get vehicle. So all of these will have to be implemented by whoever is implementing the builder interface. In this case, we have the truck, the car, and the motorbike. So as you can see here, the change that has happened is this class implements the builder interface. It has a build body. You can add in features or whatever are specific to this particular truck. Now, please note that in this case, all the different kinds of vehicles can have different kinds of specifications inside a particular method. So which is why we have exposed common methods and then we are implementing them inside the respective classes. The build body, insert wheels and add headlights, and you define them here, implement them here, and then we move on to the car. Similar way, it has implemented all of the methods here. And the motorbike, which has again implemented all the methods. And finally, moving on to the client class, how does that look like now? So we enter the vehicle that we want to build. We create a new director here. We instantiate the director. And we specify based on the vehicle type, we specify the builder, like what builder is supposed to be, provided to the director in order to build that particular vehicle. So if the vehicle type is a car, the builder will be type car. If it's a truck, it will be type truck. And if it's a motorbike, it will similarly be a type of motorbike. And how are we going to build this is by providing that particular builder to the main director. But the director is going to construct that builder and add in all of the features. And finally, when you do a product.show, it is going to show you whatever has been added to that particular vehicle.
Yeah, who had picked up the...
Sorry, did anyone have a question? I just heard something. Okay, maybe not. Okay, so let's go through this particular video. So what, so basically this is essentially the client class, and we will be just entering the type of the vehicle that we want to build, and then we'll see how it looks like. So the type here is car, the product. So as you can see here, the result is the product completed as below. This is the body of a car, 4 wheels are added and 2 headlights are added. And this comes from product.show. So essentially the first step here was calling upon builder equals to new car, then passing on this particular builder to the director class, the method construct, which kind of constructed that product body. And then it gave you a concrete product. And then the product, we called upon builder.getVehicle to get that particular product. And then we do a product.show to actually see what has been added or what has been represented in that car vehicle body. Similarly, if we enter, okay, we are running it with a parameter of truck, I guess. Okay, a motorbike. And so this one will show you that it's the body of a motorbike and 2 wheels are added to the motorbike and 1 headlight has been added to the motorbike. So that's how it looks like, and that's how it constructs the builder. Okay. So moving on to the structure, basic structure diagram of a builder pattern. So as we saw, the client that calls upon the director, which takes in the builder based on whatever type is provided. and then it kinds of builds the product, and you have the concrete builders here, which will all implement the builder interface and build products or add features in their own way, and they will result in a concrete product. So this is just a diagrammatic representation of what we just saw in the code. And I will share the links to where I found these good diagrams from so that you can go through them later. But yeah, this is how it would look like represented diagrammatically. When do I use this pattern? Okay, one basic thing will be whenever you see that there are too many constructors or there are too many parameters, which might lead to a large number of constructors, that is the place where you can actually substitute that with a builder pattern. And as we saw, we do not need too many constructors in that case, because that would kind of make the code very messy and not clean and very difficult to maintain. When your client is expecting different representation for the object that's constructed, for example, let's say they want a vehicle with 4 features and they want another vehicle with 3 different features. So that, as we covered in the example, there were 3 different types of vehicles, and although they were implementing common methods, but the features in them are quite different. So in that case as well, you can apply the builder pattern. And when the process involved in creating the object, yes, if it's more complex than usual, due to the large number of parameters, both mandatory and optional. Now that's same as not using like the telescope constructors, but just putting down a pattern to define all of them. So that is when I can comfortably use the builder pattern. The advantages of using the builder pattern, again, it quite follows the single responsibility principle. We do isolate the creation code from the business logic. We do minimize the number of parameters in the constructor, even when the client is expecting a different representation. We do know that we have separated out all the representation in separate builders, which is why it's easier to maintain that code, to read that code. It's highly readable as well. And it reduces the complexity to a great extent. Okay, one of the cons could be, again, I mean, if you have a large number of, if you have too many parameters, for example, and you need to create like separate builder for multiple different types of products, essentially increasing the code base and increasing the complexity. So there has to be a trade-off between when you can use this versus when you cannot use this. So you have to essentially know that from the task that you have in hand, that whether or not making the code a bit complex, but not too complex, essentially just define the kind of parameters that you're using, essentially restrict the features that you are restricting the features that you're using, things like that. So the overall complexity might increase if the pattern requires creating many new classes. So there is always a trade-off between using the different kinds of patterns, but yeah, I mean, that all depends on what is the kind of problem that is currently that you're trying to solve. So that is a disadvantage of this. Okay, so we have 2 more patterns. Do we have any questions till now for the builder pattern or for anything else? Okay, anything in chat, Irina?
Yes. What if one object, such as truck, has a feature that does not exist in the other objects? For example, a freezer unit.
Sorry, Irina, can you go again? I heard till if there is an if there's
What
a
if
feature in an object
they,
that is not there.
Yes, for example, truck has a feature that does not exist in other objects.
Okay. So if one particular class has a feature that does not exist in another object, is that it?
Yes.
Okay, so in that case, well, one way would also be to use kind of and maybe an abstract factory, because that helps you with providing because there's an abstract class that you're extending, you can also add in your own features to a particular class, and even if they are not in the other classes. With the builder pattern, builder is essentially an interface. So essentially we define the common methods that will definitely be present in all the other different objects. So that is how the builder pattern works. I mean, that is probably a better place to use the factory or the abstract factory. Does that help?
I hope so. And yes, oh, thanks.
Okay, all right. All right, so moving on to the Singleton pattern. A Singleton pattern is quite an important concept. Like in general, if you are into Java, you will come across a Singleton class somewhere down the lane when you're working. Now, what this pattern does is it has a very specific purpose. It ensures that a class is only one instance, and it provides a global access point to that instance. That is it. I mean, if you come across a problem that needs to cater to this kind of scenario, that needs a global access point to only one instance, then Singleton pattern is the one that should be used. Why do we need it? We need it in certain cases as like having a single DB connection. If we need to have a single DB connection to share between multiple objects, because creating a DB connection all the time for every object might prove to be very costly. So in that case, we can go ahead and create declare it as a Singleton class and then create an instance and have all the objects use that. Or for example, the configuration manager in an application class, or an error manager, for example. So all of them will deal with problems that need only a global access point. And we use them because creating multiple instances are usually costly or heavy on the application. So this is just a diagrammatic like representation of how it looks like. You just have, one instance, and all the objects are kind of calling on that instance because that's the only one available, and that is the least expensive option here. Okay, so this example is how a not Singleton class looks like, which is why I have named it as not Singleton. This is before applying the pattern. So as you can see, this class has only one integer variable called object, and I have a getter and a setter on that. Now I define another class called getValue. What this does is it has two methods, and it has an object of the not Singleton class. Now, what the two methods are doing here is if object equals null, then you create a not singleton, then you create that object and print the value of the object. And then you set the object to a particular number, and then you print it again. Now, as you can see here, in both the methods, we are creating the object if it is not null. But in true sense, this object wouldn't be initialized unless it has been used at least once. So let's say I define another method using the object variable, or to get the value of that variable, I have to keep checking whether it's null and then create it if it's not null, and then get the value of that particular object. So, and when I move to the main class, again, I am declaring that object. And if it's null, I'm creating that particular object and then setting the value. And then I'm calling on the get value, this class's methods, the get value of object 1 and get value of object 2. So you can see that all the initialization code, if object equals to null, create that. That is like repeated throughout throughout wherever it is needed. And this is exactly what happens when, let's say, for example, we want to create multiple database connections. So wherever you need them, you need to keep checking whether there's an existing connection or not, and then keep on creating connections. So that will cause two problems. One is repetition throughout your code base, and secondly, it might be heavy on the application. So to prevent this, we convert it into a singleton pattern. But I think before that, we can see how this particular code execution will look like and who actually creates the object. So, okay, so let's run this class. Okay, so as you can see here, when I ran this class, it says main created the object, which is true. The object was null here, so main created it. And main returns 0. Then it went to get value dot get value of object 1. It's again created that there because the context is lost. The object is now null. So it creates the object again, and it gets a value of 1 then, and get a value of object 2. Because it's in the same class, it's a global variable. So basically it just gets it value from there and it prints it. So this is how it would look like if we are not using a singleton pattern. Now moving on, when I use a singleton pattern, this is how it should look like. I have an instance, and I have in the singleton class, I have an instance and I have a get instance. So get instance should be the one that the client should actually be calling to get that particular instance and then to use it to do its servicing. So if I go there, if I go to the singleton class, this is how it looks like now. I provide an instance, I provide an instance, singleton instance, and I do have the getters and setters still on the object, but I do provide a get instance method. The instance variable here is, and it should be always private and static. And I provide a static constructor for get instance. So what that does is essentially put the initialization code. If the instance is null, then my instance will be new singleton 0 because I am declaring an object to hold its variable, to hold the integer, and then it returns the instance. So these are the two basic requirements of declaring a singleton class: a private static instance and a public static constructor. Now, what is one obvious mistake in this code? Can anyone identify with this particular method, with the get instance method? Can anyone identify and like just share your thoughts?
Okay, you
Anyone?
better show the previous one.
Yes, okay. Yeah, what is, yeah, the get instance method? Okay, if anyone wants to share, otherwise I'll just move on.
So, the proportions in chat. Services, a database connection. Probably it's for previous one. The question set object. And also another thread can call at the same time and both create two objects.
Sorry? Didn't get
Another
that.
thread can call the same time and both create two objects.
So you mean this one, the get instance method?
Yes.
Okay. It's actually related to, okay, let me give a hint. What if there are, now we discussed that the get instance will actually be used by multiple clients, right? Multiple objects. So what happens when multiple objects are trying to actually call on get instance?
It's not, is it, it's not singleton anymore, right?
It is singleton, but what happens to this particular method? That is what I'm looking at. Like if I have two people trying to, or two objects trying to get the value of get instance, get that particular instance, then what happens? Like I want, like there is a concept called multi-threading, right? In Java.
Yes, so they both create two objects.
Yes, so essentially, yes, right, Elena. So it's, yes, so essentially, it's not thread safe because the get instance method, so any number of threads can actually go on and then they can keep on increasing the value of that particular, all of them will have separate objects at a single point of time, which we do not want. So what we are going to do is we will put in a synchronized keyword to the get instance method to make it thread safe so that multiple threads while accessing this can do so with without any conflict. And again, once we are inside that particular method, we will just be putting a synchronized locking on the entire method. This is called as double locking in Java. This is just to ensure that even if multiple threads have reached till this point, they have only a single instance, like just that one specific instance of this particular class. So essentially, yeah, that's it. That is the only change that we need to make it thread safe. And this is how the Singleton class would look like after we are done. And now the get value method, the get value class, where we had the two other methods. The change here is instead of creating the objects, we do a singleton.getInstance.setObject1. And in the second method, we set its value to 2. And in the main method as well, we just call on that particular instance.get object. Instead of creating that object again and again, we have now reduced the code to getting that single object which is existing. So now if we run this particular code, this is how it's going to look like. Okay, so we run the Singleton class and you'll see that it's been created just once. and it says main returns 0, get value returns 1, and get value return of object 2 returns 2. So instead of having it created multiple times from multiple classes, we have just created one single instance, and then we are using the classes to set the value or get the value of that particular object. So that's it for Singleton, I guess. Yeah, so when do I use the pattern? Now, as I mentioned, Singleton has very very design specific usages. It has very specific applications for database connections, for resources that are expensive to create, for configuration managers, for error managers, and things like that. We use this pattern. The pros are that it guarantees a single instance. Of course, that is what it is meant for. The Singleton object is only initialized once, only when it is requested for the first time. Otherwise, it's not created. And it has a global access point to that particular instance. Now, cons of this particular method, if you have a multi-threaded environment, then yes, you do need special treatment. You need to look at the code very carefully, design it very carefully, and it kind of violates the open, closed, and single responsibility principle. How it violates the single responsibility principle is that it also controls how objects are created and manages their life cycle as well. So that is like doing two things at a time, not one thing. And how it violates the open closed principle is it inhibits if like Singleton class is inhibiting inheritance, it's no longer open. And if the Singleton class is allowing inheritance and it is open for extension, as suggested in the open closed principle, it can no longer enforce the Singleton pattern. So the basic idea of Singleton pattern, therefore, is to just meet very specific requirements. And yeah, I mean, it's easy to identify which of your requirements will actually cater to a Singleton pattern and be used there. It's difficult to also create unit tests for this because it has like a private constructor, and you cannot kind of override static methods. It's like very tough to do that. So yeah, I mean, there are a few disadvantages of the Singleton pattern, but nonetheless, there are situations where it proves to be very useful as well. Okay. So moving on to the last pattern, and then we can take the final questions. The prototype pattern. Now let's say we have to create an object. We have an object and we want to create a copy of that or a duplicate of that object. So in general, how do we do it? In general, we probably would create a new object of the same class and copy the fields one by one. But one problem with that is there might be private and as well as public fields in the main class. So we might not be able to actually copy down the private fields. So that will be one problem with the copying. So how does prototype pattern helps you? As the name suggests, it lets you copy the existing objects without making your code very dependent on the main class. It just lets you clone the objects, and all the cloning process or making that exact copy process is delegated to a separate method, which does all the cloning and which defines an interface. And then all the objects can actually, all the classes can actually just use that to make an exact copy of that same class. Now let's go to an example. It will be clearer. Let's say I have this class vehicle. I have three members here, model, ID, and color. Color being the private member here. And I have two constructors. One is a default and one will have like the three parameters. And I have a show vehicle method. Let's say I want to clone, or let's say I want to copy or make an exact copy of this vehicle object. Now, this is my client class where I'm trying to make a copy. So I define one is a vehicle, and I define a method called duplicate, and I try to create a new vehicle. But as you can see here, when I try to clone, when I try to add in the members from the main class, the private members, now color was a private member, so it is not, it won't allow me to set that member on this cloned object. So color is private, so it wouldn't allow me here to, or it doesn't even show that. So private members are not accessible outside. So what is the solution to this one? Okay, so I delegate the cloning of this particular vehicle to a method called clone. What clone is going to do is it's going to return me an exact replica of the vehicle with the model, the ID, and the color. Note that even though color is private, I can use it inside this particular, because I'm defining this clone inside the same class. And the small change that has to be done is the vehicle implementing a cloneable interface. Cloneable is already a defined interface in Java, and you just need to implement that and define the clone method with whatever the requirements are, and it works. So now the client class, what we need to do is just define a vehicle clone as vehicle.clone and return that cloned object. So that will be an exact copy of whatever your original vehicle is. So that's the prototype class, the client class. As you can see here, I have defined a vehicle. I have created a vehicle which is called sedan AB123 in red. And I do the original vehicle here. Sorry, the original vehicle is this one. And then there's a clone vehicle, which is nothing but client.duplicate. That is calling on this particular method from the client. And that will provide us with a clone. So how does this look like is this. So when we run this particular method, as you can see, it says the original vehicle details are sedan AB123 in red. Next, when we have cloned the vehicle using client.duplicate, that has called on the clone method of the original vehicle. And so we get the exact same details for the vehicle when we are cloning it. Okay, so that is it for this one. Okay, moving on. Yeah. So this is, again, the structure diagram for the prototype pattern. So the client, you have the main client class, which is actually just calling upon the clone method of the existing prototype, and then it builds the concrete prototype. And then we have a subclass prototype, again, building on from top of that. And you return the concrete and the subclass prototypes with whatever fields have been initialized. Now, what it shows here is that the concrete prototype has a separate field called field 1, and subclass prototype has again another field called field 2. So essentially, although both of these classes, you can clone on the original prototype class, but also in the class that you have been using, you can add in your own methods. So essentially, this will be useful in scenarios where you have to add on additional features or over and above the original features that are required. So I can clone the existing vehicle, but let's say I want to add more features to my vehicle. I can declare them only in the vehicle, only in the client class and not in the vehicle class. So that's the prototype diagram. When can I use this? When creating, when you need to create a copy of an object and you know that a similar object is existing, and creating a copy would be a costly affair and requires a lot of time and resources. The advantages of this is that you can clone objects with ease by just implementing the clone method. And you don't have to be dependent on the concrete classes at all. It could provide as an alternative to inheritance instead of creating like many classes with different configs. You just need to have one class and copy it with different configs every time. And also it gets rid of the repeated initialization code. So you can only just clone objects. Another benefit of this is even if you have private members in your classes, in most of the cases you will have, it gets you through, the cloning method will get you through to the private members as well. So that's the advantages. And disadvantage is now there might be instances when some objects might have circular reference to their classes. Now, circular reference is when you have two objects, object A and object B. Object A is referring to object B, to some variable in object B, and then some method in object B refers back to object A. It's quite a complicated reference and a complicated step in Java, but if that is a thing, then cloning the objects might be very tough. So that is when you would not want to use this particular pattern. Okay, so I think that's it about all the design patterns. I do have some examples, some very simple examples for you to consider and take away from the session and try implementing them with whatever we have learned today. But yeah, I mean, I can take questions. We have the last 5 minutes. So if anyone has any questions or anything else, like we can answer them now. Yeah, I can't see the chat.